Hello, everyone. So we're going to keep moving through our getting started with R by talking about functions. And I forgot to do my task on commands and calculations. Yes, I was able to complete the practice. And let's take a real quick look at this practice. All right, throughout these are going to be these practices. There's small places where you can do just a little bit of R coding so that you understand what's going on. If you can't do the practice or for some reason it doesn't work for you, you got to let me know. I'll be happy to help you through it, okay? And so I'll just give you an example doing the first one. Find the sum of 2 and 3, store your results in a variable. Okay, easy peasy. So we're going to do A, and then we're going to use the assignment operator and 2 plus 3. Bingo. Okay, but wait a minute. I need to display A by retyping it out. And then I can come right down here and I can click run. All right, it runs my code right over here, just like it would in the R console. And it gives me some feedback. It says, oh, wait a minute. Did you define variable B? Well, wait a minute. I haven't done anything on B because I haven't done all the rest of those. If you do the whole thing, all right, and you can click the little solution button if you want to cheat. But there you go. If you can do the whole thing, you can click run and it will tell you, hey, you did it right. For the most part, these practices give you this kind of feedback. Not all of them do, but for the most part. In any event, make sure you get through those and do each one of those as you go. So let's go back to the home button, the home page. And I'm going to come down here and I'm going to cheat a little bit and just go right straight on to functions. Within functions, we're going to do learning statistics with R, section 3.5 and 3.6. Okay, so let's get started and dig right in. So here we are, 3.5. I'm going to turn on my annotations. Incidentally, if you go up to the module that says before getting started in the class, right, before the class starts, if you go down there, there's actually a link to be able to join the hypothesis.is group that handles these annotations, and then you'll be able to see my annotations in your textbook, should you want to. All right, in any event, we're moving on, and we want to talk about something called functions. Now, we've talked about operators already, and those are a special kind of function. They're kind of a binary function that has an argument that goes in front and an argument that goes in back. Now, there's also trinary operators and whatnot, but we're not going to go there. Those are a little more complicated. For the most part, what we have is, operator like a plus, a minus, a subtract, or a power sign. But those are a little bit limited. All right, what if I have more than two arguments, right? Or I want to do more than just one operation in here. And so we have functions that allow us to take in a number of arguments and do some kind of procedure. So let's start out and let's look at a really simple one. And that's the square root function. All right, so let me come back here to RStudio Cloud. And I've already typed a few things in here. So let's come down here and I have functions in R, and we have things like operators are a special kind of function. 20 plus 30 gives us 50. Yay! So let's go on and let's talk about the square root. All right, so the square root function, it starts out, it has a name, it has an argument, and then we can run that argument. So let me go ahead and get rid of this. And let me run that. And boom, I get 10. Square root of 100 is 10. Yay, cool. And I can do the same thing I could do before with the operators. I just paste this back. I can store it using the assignment operator into a variable. All right, let me go ahead and I'm going to wipe out my global environment here. How am I doing that? I click on that little broom that's right up here, and I include hidden objects. I'm going to click yes, and then boom, my environment's gone. Yay! And so I'm going to run this, and all of a sudden, boom, square dot root equals 10 right there. And I stored that right in there. It didn't print out. Why? Because I didn't tell it to print out. I told it to take the value and put it into square root. Okay, so let's keep on a plugin. So we can do a few other things. I've got some examples here, but let me go ahead and let's put this to where I can do it one at a time. And so we're going to do our, function arguments, their names, and their defaults. So let's start out. Let's use the function round. Round is kind of fun because it has two different functions. And so the first thing I'm going to do is let's just type in round, R-O-U-N. Oh, and it pops up. This is called code completion. And it pops up a little thing to help me complete it. And oh, I want round. But what's really neat about this is it also pops up some information. The most important here is the arguments that round takes. So I have X and I have digits. And then it says equals 0. Well, that equals 0 is the default value for digits. But hold that thought for a second because we'll come back to that. And so I'm just going to click in round. And so the first thing I'm going to do is let's just put in, I'm going to hit the tab button. And what the tab button does is it does that autocomplete. And boom, these two pink little thingies here, whatever those are called, those are the arguments. And what's nice is for built-in functions like this, it's definitely going to have documentation there. It tells you what each one of these are. So in the case of X, it's our number or our list of numbers. All right, so round, let's do pi, 3.1415159. 3.14159. Okay, great. That's all the digits I can do. You might be able to do more, but that's okay. All right, X equals 3.14159. And then let's go ahead. We're going to hit digits. And let's say we want to do it to 2 digits. Bing. Bing, that's cool. Now, what's really neat about this is the named arguments. The fact that I can say that's X, and that usually just means a number in R. And then digits is to how precise, how many digits past the decimal point we want to go, or to the left of the decimal, or the right of the decimal point we want to go in precision for our rounding. That's really cool because what it does is if I'm coming back and reading my code, say the next day or a week later when I can't remember all that stuff I figured out about it, well, I know more information. It gives it document. I know what X is. I know digits. I can figure that out, right? Another thing that's really nifty about that is notice if I use this one, what did I do there? Well, I flip-flopped the order. Well, if I tried to do that in Microsoft Excel, it would just say, can't do it. That's wrong. Because it uses the order of the arguments in order to determine what those are. Here we have named arguments, so I can flip-flop the order just like that, and bajinga, I get the same thing. Now, the next thing that's really important, and I told you I was going to tell you about this, is default values. So in a function, each argument can have a default value. All right, and what's that default value? Well, X doesn't have one, so we have to put in, and oftentimes when it's X and it's the first argument, we just put it in, 3.14159. That's kind of standard practice in R. And then digits, but I don't want to put digits in. But notice here it says digits equals 0. The default value is 0. So if I just omit that argument, what happens? R just assumes 0 for it because that's its default value. Okay? And then what's one other thing that we can do? Well, another thing we can do is if we look at this, there is kind of a style that is very R-ish and I think is actually pretty darn good in terms of being readable. And that is I can take and put each argument on its own line. And so open parentheses, argument, comma, then the last argument doesn't have a comma after it, right? That's how R knows that's the last argument to look for. And then my close parentheses. And guess what? That's going to give me exactly the same results as I had before, right? So if exactly the same results that I did before. It just makes it a little easier to read. Now, for this little simple function, you're saying, well, why would I want to do that? Well, for a simple function, you probably don't. But for some of the more complicated functions, especially when these arguments get longer, because they will get longer, then it makes it a little easier to read. It doesn't make it a little easier to read. It makes it a lot easier to read. Okay, and so that leaves us with one more thing that we need to understand about functions. What happens when they go bad? Well, here's an example. So I'm doing round and I tell it digits equals 2, but I didn't tell it the x. What's going to happen? Let me get rid of that because that's a bit of a dead giveaway. I'm going to hit run and it says error! Argument x is missing with no default. So for the round function, the number that you want to round, you can't leave that off because it doesn't know, R doesn't know what number to round if you don't put something in there. You can leave digits off because if it does, it has a default value. But there is no default value for x, and so you have to have that in there or it's going to throw an error. Now, I want to show you one other thing. If I were to, let me get rid of this. If I were to try to knit this document the way this is, it would give me an error. It would say, I can't do that because this code chunk has an error in it. But let's say I want this to be here. And I note that this does not run, right? Because it's wrong. There's an error in it. I have left off an argument that needs to be there, but I still want it to knit. Well, I can tell R, right, comma, and I'm going to put a comma after that little R there, and I can put options inside of this code chunk. And it's a little like an argument. And so what I'm going to do is I'm going to say eval, all right, and notice it helped me with auto completion. And then I'm going to set that equal to false. When I do that, when I hit knit, this will be, typeset into the document like every other code chunk, but R won't run it. All right, it'll just be, it won't do anything with that. And so if I want to include, this example of how not to use the round function, well, I can do that by putting eval equals false. All right, let's keep going. And the next thing I want to do is we're not going to get into user-defined functions particularly. You can write your own function, all right? And I regularly write my own functions because I have to do things that are a little more complicated than maybe what we're going to get into in this class. But I really think understanding the basic idea of how to write your own function will help you understand a little bit of what's going on, kind of the anatomy of a function to figure out, well, a little more of why it works the way it does. So I want to show you how to do that, though I'm not going to show you really enough to be proficient at it. So don't get too worried about it for right now. I'm really just showing you the anatomy of how you build a function so that you can use the pre-built functions with more confidence. So I'm just going to make myself a new little code chunk here. And yeah, spoiler alert, I'm using this code right down here, but I want to type it out for you bit by bit. So let's make a new function that rounds. All right, so a new round function. So let's do new dot round. All right, and naming a function is just like naming a variable. All the same kind of conventions and rules are about that. And I'm going to use the assignment operator. And then I have to use a function to create the function. And that function is function. All right, so function, and I'm going to do open parentheses and bing. And what I'm going to do inside the parentheses after function is define the arguments for my new function. And what is an argument? Argument is the information I need to give my function in order to do something. And so what do I need to round? I need to have a number, all right? And, it's typical to call that x, but let's call it x1 because we'll denote that from the round function. And I need to know to how many digits past the decimal point I want to go. So let's go digits, GITS, digits 1. And let's set a default. All right, the default for the regular round function is 0. Let's set the default for this one equal to 1. All right, easy peasy. All right, bing. And so now we defined our function and its arguments. So that's the first part. We have the name of the function, and the information we're going to give to the function so that it can do its job. So the next thing I'm going to do is I'm going to create a code block that'll define this, what the function does. To do that, I'm going to hit the curly brackets. So the curly brackets are right up above the, they're usually above the return or the enter key, and they're by the square brackets. So you have to put shift to get the square brackets, and then that gives you the curly bracket. Okay, I'm going to hit return. And now what I want to do is put in the procedures that I want to do. So this, I want to take this x1 and round it to digits 1, number of digits past the decimal point. So let's do new dot number. All right, or I'm sorry, we'll do round dot number. Dot number. All right, that's my rounded number. And I'll use my assignment operator, and I'm going to cheat. I'm going to use the round function. Round. And then we're going to say, x equals x1, right? Because rounds argument x is going to equal the x1 argument that I give it. And digits, all right, equals our digits 1. Yeah, I know, it's a little confusing. And I could have called those x and digits and had x equals x and digits equal digits, and it'll work just fine. Feels like it feels wrong, but it will work, I promise. And there we go. And so there we go. We've got the next part. This is what the function's going to do. Now this isn't very cool, I know, because we're basically just repeating what another function's already done. But you could have like a whole bunch of different operations that happen in here. And it's actually pretty slick, because especially if you have to do the same operation over and over again. Like for example, one way I'll use a function is I'll make a function that makes a graph where I give it some data and it spits out a graph. And I'll put all the fiddly bit kind of formatting I want in the function, so that when I want it to do a graph formatted this way, for this data, I put this data in it. But I want it formatted the same way for that data, I'll put that data in it. And it actually is pretty useful. But in any event, for right now, we're just keeping it simple. This section does something. And now we want to take the output of what we've done and return that. And so we're going to use the return function. Return. And we're going to do round.num. Okay, and let's run this. And lo and behold, nothing happens. Oh, well, actually, yes, something did happen. We created a new function. So here, there's our values. Now we have functions in our environment. And it says we have a function new.round. And this is a kind of a brief summary of its definition. If you click on this right there, it'll come through and give you a complete listing of its definition. But for right now, we don't need that. We're going to drop this down. And this over here is really handy when you don't know where it was originally defined. It's like in a really big document with all kinds of stuff. Well, you can click there. It gives you a simple way to find that information out. But for right now, there's our new function. Now let's call this function. We have new.round, and we'll do open parentheses. We'll make is 3.14159. And what happens if we just run that? Our default for digits is 1. Let's run that. Boom, 3.1. What if we want to set digits equal to 2? Oops, sorry. Nope, that won't work. Actually, let's run that real quick. Don't ask me why that worked. That shouldn't have worked. But in any event, there we go. Digits 1. That will work. Bing! Yay! And we can do other things, just like with any other function. We could take this. Okay. And I'm just going to copy that so I don't have to retype it. And let's call it A. and Control V. Bing. We paste that in there and run this, and bing, we have a new value A that's 3.14, which is our round. All right, just like that. All right, there's how a function works. Now, there's a number of things I haven't told you about functions, things like scope and what data the function can see, what data it can't see, how you get it from the global environment to the function environment, all this stuff. We're not going to worry about any of that. Just don't worry about it. You probably don't have quite enough to be completely fluent with how to write functions, and if you go in and try to do anything more complicated than this, you may get a little frustrated. That's okay. Don't worry about it. The only reason why I'm showing you this is not so that you know how to make your own functions, but so that you understand the anatomy of a function so that you can better use the functions that are already predefined. And so for the purpose of this class, we're going to stick pretty much with predefined functions. If you want to know more, well, if you want to know more and get a little more sophisticated, um, I suggest taking a class in the spring called Econometrics, which is Econ 426. All right, that leaves us where we're at. I won't show you one more thing, and basically we've already seen it. So if I keep going to the next one and we let R, R help us out, autocomplete using the tab button. And now I've shown you that when I hit that tab button in RStudio, I will oftentimes get extra information. All right, use that. It'll tell you what the arguments are. Sometimes it'll even help you complete the name of the function. It'll give you lists of functions that you can kind of tab through to try to figure out what it is. And so that's what that autocomplete is. It can be a little annoying too. Sometimes it eats your closing parenthesis and whatnot, so you have to be a little bit careful. You can read through this. This is a really nice summary of the autocomplete, but overall, it's pretty darn handy. Okay, and with that, I will see you in the next video.